I want to discuss an important type of problem that very well might be on this exam that's coming up. And problems that are similar to this would be in the review problem section of Chapter 3. And the particular problems I'm thinking about are number 16 and number 26. And of course, the solutions of those problems are available also. So you should look at these problems after you've listened to what I have to say in this pencast demonstration. This is going to be a typical kind of percentage problem in which we're going to be talking about an alloy. And I'm going to give you some information that you might, in some of these problems in the book, by the way, you might have to look up in a table of densities some information. But I'm going to tell you, for example, zinc, the element zinc, has a density of 7.13 grams per cubic centimeter, and the density of lead is 11.35 grams per cubic centimeter. I have a table of densities in the text, and you would find those densities there. Now I'm going to tell you that I have prepared an alloy of zinc and lead. Those are the only two elements in the alloy, and that it's 26.8% by mass zinc. And I'm going to start asking some questions about that alloy. And I'm also going to tell you that the density of the alloy is 9.41 grams per cubic centimeter. As you know, an alloy is a homogeneous mixture of two or more metals, and essentially being a mixture, it can have any particular composition, and I've made this particular composition 26.8% by mass zinc. Most of these alloy compositions, by the way, are given as per mass. So in order to solve some of these problems, you might want to start by writing what you really mean by percentage. This is going to be a common theme in this class and also in subsequent chemistry classes. You want to start with an appropriate definition. So if somebody says an alloy is 26.8% by mass zinc, you might want to write that as a ratio of 26.8 grams of zinc for every 100 grams of alloy, and write it out explicitly. Therefore, of course, you can conclude what the percent lead would have to be in this alloy, given there are only two metals. One way to do that is simply to take 100%, that's the two together, and subtract from the 26.8%, and that's going to tell you that the percent lead would have to be 73.2%. That's one rationale for doing that. Another way of looking at this is to multiply two conversion ratios together. If it's 20, not multiply, but write out two conversions, you've got 26.8 grams of zinc is the same thing as 100 grams of alloy, then surely you could say that that's 26.8 grams of zinc for every 100 grams of alloy minus the 26.8 grams of zinc, which says, of course, that it's 26.8 grams of zinc for every 73.2 grams of lead. In other words, notice what I've come up with there is a ratio between the zinc and the lead, which has also given me, of course, indirectly the percent lead in the compound. So there's several, in the alloy rather. So there's several different ways to make that deduction. This is also an important ratio because notice what this says is that I have a recipe for making this alloy. If I give you 73.2 grams of lead, I require 26.8 grams of zinc to make the alloy properly. So I really have three ratios here. I've got the original ratio, 26.8 grams of zinc for 100 grams of alloy. I've got the ratio I've just derived about the relationship between the zinc and the lead. And of course, when I figured out the percentage lead in the alloy, I've also got a third ratio here that would be 73.2 grams of lead for every 100 grams of alloy. These three ratios are all composition ratios and allow us to solve various kinds of problems that I'm going to begin to show you. The other point here is that I've got densities of both the zinc, the lead, and the alloy. They had to be given to me, or I have to look them up or in some way know those. Those are going to be conversion ratios that convert between mass and volume, because as we know now, that's what density always does. So let's look at a question. Question A. The question here is, how many grams of zinc are in 141.3 grams of alloy? Now you probably solved that by simply multiplying 141.3 times 0.268. That's the percentage of zinc written as a decimal. But you know, explicitly what you're doing is writing 141.3 grams of alloy as a given quantity, and you're applying the conversion ratio that it's 26.8 grams of zinc for every 100 grams of alloy, and that's giving us therefore as an answer of 37.9 grams of zinc. And notice, by the way, here that I have a 3 sig fig answer based on the fact the conversion ratio is 3 sig fig. That percentage is measured, even though I gave you in this example 4 sig figs in the given, the 141.3. You do have to consider in situations where you have measured conversion ratios, such as percentages, concentrations that we'll see later, those can control the number of sig figs. You know, if I ask a secondary question here, and this may be one that is more useful to use ratios with, how many grams of alloy can I obtain from 119.6 grams of lead? Notice again, I can solve this with a ratio. I've given 119.6 grams of lead, and the ratio that's relevant here is, as always, I need the units of grams of lead down below, and I need grams of alloy up top. And the numbers that go with that, 100 grams of alloy, are the same thing as 73.2 grams of lead. Doing that arithmetic, I come out with 163 grams of alloy. That says you can make 163 grams of alloy if somebody gives you 119.6 grams of lead. And again, notice the percentage here has controlled my sig figs. In number C, I'm going to ask the question, how many grams of zinc would be added to 45 grams of lead to prepare this alloy? This is a good example of a problem that in a conventional percentage, you know, you multiplying or dividing by the percentage of the decimal doesn't solve the problem very easily. But remember, we had a ratio here that gave us the zinc to lead ratio, which also, by the way, the other way around could give us the lead to zinc ratio. I'm giving you here 45 grams of lead, and I'm trying to convert this into grams of zinc. You know you want grams of lead down below, and you want grams of zinc up top. And the ratio that works there, remember, is the 26.8 grams of zinc that's needed for every 73.2 grams of lead. When you do this arithmetic, the answer comes out to 16 grams of zinc. And notice here I get a 2 sig fig number because my given was only 2 sig figs. I just gave you 45 grams of lead. In other words, if I give you 45 grams of lead, you should be adding 16 grams of zinc to that to make this particular alloy. Now, the next question is a good example of being careful with your units. The question here is, how many grams of lead are there in 119 cubic centimeters of alloy? You know, we had a previous question where we asked how many grams of, I believe it was zinc in so many grams of alloy, but here I'm asking grams of lead in so many cubic centimeters of alloy. As soon as you see volume of alloy, you know the percentage composition only works for mass. It doesn't work for cubic centimeters, so you're going to have to turn the cubic centimeters, 119 cubic centimeters of alloy, into the equivalent number of grams of alloy. And way back there, remember we told you the density of this alloy is 9.41 grams of alloy for 1 cubic centimeter of alloy. Applying this conversion factor would tell me how many grams of alloy 119 cubic centimeters of alloy is. But that's not the question. The question is how many grams of lead. So notice the next conversion would be the relationship here that we said that it was 73.2 grams of lead in 100 grams of alloy. Notice I'm using two conversion factors in tandem to come up with a final answer here, which would be written as 820 grams of lead, which, by the way, is a 3 sig fig number. If you look at your calculator, well, my calculator gave an answer of 819.68628. And if I want 3 figs, there's my last fig that's supposed to be showing. I look one place to the right, it's greater than 5, so that 9 gets kicked to a 2, and I write 820 using an ambiguous place holding 0, but that is a 3 sig fig number. As we said before, I could be handed the number 820 grams, and I wouldn't know whether that was a 2 or 3 sig fig number. In this calculation, I know it is, because every one of my given values was 3 sig figs. In the last question here, what if I asked how many cubic centimeters of zinc would be added to 90.3 cubic centimeters of lead to prepare this alloy? I've given you the recipe for the alloy. And of course the recipe for the alloy is given in terms of grams of zinc for grams of lead, or the other way around, grams of lead for grams of zinc. But the question here is how many cubic centimeters of zinc, again a volume. So, and also the given was so many cubic centimeters of lead. So I start here with the fact that I was given 90.3 cubic centimeters of lead. And the first thing I have to do is ask how many grams that is. And the answer given in the beginning of the problem is it's 11.35 grams of lead for every 1 cubic centimeter of lead. Then I can carry on by now looking at my ratio, because now I have grams of lead. And it's 26.8 grams of zinc for every 73.2 grams of lead. Now I've got grams of lead turned into grams of zinc, but the question was cubic centimeters of zinc. And 1 cubic centimeter of zinc is the same thing as 7.13 grams of zinc. As always, you're starting out with cubic centimeters of lead. That's going to cancel with cubic centimeters below the fraction bar of lead, below the fraction bar in the first conversion. Now I've got grams of lead. Grams of lead cross-cancel with grams of lead in the second conversion ratio, leaving me with grams of zinc, but the question was cubic centimeters of zinc, so grams of zinc cross-cancel with grams of zinc and the density written upside down to give me a final answer, which is coming out cubic centimeters of zinc. And the answer for that, arithmetically, comes out to 52.6 cubic centimeters of zinc. Again, I want to remind you here that to do this with a calculator, you would type in 90.3 times 11.35 times 26.8, then go divide 73.2, and again divide 7.13. Make sure you do that properly with a calculator to come out with this answer as 52.6 cubic centimeters of zinc. In summary here, there are 2 kinds of conversion ratios that are being used for all of these problems. One are mass-mass relationships derived from the mass percent composition, and the other are the densities, which are given values, numbers that have to be given to you. Density converts between mass and volume, or volume and mass. The mass-mass conversion ratios, whether they're percentages or whether it's a mass of one element to the mass of the other, these are all conversion ratios that convert only masses. So in this last problem, if you're given cubic centimeters and you want to know cubic centimeters, you're going to have 2 densities showing up in that type of a calculation. You have to get accustomed to watching your units carefully as you're working through these problems.